Start streaming.
I
I
think
think
we
we
should
should
be
be
live.
live.
Yes, we are live.
Yes, we are
अब
live.
देख लेता हूँ
अब
आज.
देख लेता हूँ आज.
I
I
think
think
we should
should
be
be
live.
live.
Yes, we are live.
Yes, we are
अब
live.
देख लेता हूँ
अब
आज.
देख लेता हूँ आज. Think
ये क्या हो रहा है
ये
यार?
क्या हो रहा है यार?
Yes, we are.
Yes.
तो तुम्हारा आवाज
तो
क्यों
तुम्हारा
आ रही
आवाज
है?
क्यों आ रही है?
एक बार स्ट्रीम खोल
एक
के
बार
देखिए
स्ट्रीम
जरा.
खोल के देखिए जरा.
आई थिंक दो बार आवाज इसलिए आ रही है क्योंकि रुक जा. अरे ये फेस टाइम स्विच स्विच क्यों नहीं कर पा रहा हूँ. रुक जा, मैं देखो करता हूँ.
We are live. अब देख लेता हूँ आज. Think
ये क्या हो रहा है?
ये क्या हो रहा है यार? We are live. अब देख लेता हूँ आज. Think ये क्या हो रहा है यार?
बोल एक बार कुछ.
बोल एक बार कुछ.
टेस्ट
बोल एक बार कुछ. हाँ तो ये तेरी आवाज बट कम. मेरे को आई थिंक यहाँ से बढ़ानी पड़ेगी.
बढ़ानी पड़ेगी.
आदित्य फुल. ऑडियो इनपुट कैप्चर थोड़ा और बढ़ा देता हूँ. हाँ बोलना जरा कुछ.
बोलना जरा कुछ.
हेलो. I'm audible, loud and clear.
हाँ बोलना जरा कुछ.
हेलो.
अब आ रही है.
अब आ रही है. Proper.
Okay, we can
Okay,
start.
we can start.
Yes.
Cool.
चालू हो गई.
हाँ कब से चालू है?
कब से चालू है?
और मेरा पेट दिख गया होगा लोगों को. तो fuck.
जीरो लोग देख रहे हैं
लोग
अभी
देख रहे हैं अभी तो.
कोई पीछे जाके जबरदस्ती देखता जाएगा तो देख
जाएगा
सकते.
तो देख सकते.
All right. So we have done. We're doing the study modules of OpenUSD. We have
मेरे को स्क्रीन नहीं दिख रही तेरी.
my bad. Okay. दिख रही है अब.
Yeah, let's go guys. We are on
Okay, so we have basically done the overview of the stage
Wait, do you think my voice might be echoing on over there?
on the stream.
Yeah.
I don't think so. So
What about your
we
voice?
have basically done the overview of the stage.
Wait, do you think
No, it's fine. It's perfect. Bye.
I was just making sure. I was like a bit curious that it might be echoing.
It's not echoing. It's fine. Cool. So today, it's basically 10:09 right now. We're gonna do like a speed run of, you know, the next part of this module. We have basically covered setting the stage. This was like some high level stuff about the stage. Uh, Done the overview, done the stage itself. Then yesterday we talked about prims. We read about prims. We saw how we could create a new prim, define a new prim, you know, basically retrieve how all of its childrens and help identify what kind of data or what type of prim it is by these Python functions over here. So that was pretty insightful. We did like a quiz, 10-question quiz yesterday as well. And yeah, so today we're gonna be moving towards properties. This is the new part of this module that we're gonna study. Um, I think this is gonna be like a relatively shorter, you know, thing.
Yeah.
And so I think we can do like a couple of these today: time code and time sample and properties.
Yeah.
But yeah, let's see. And then let me just quickly add this to. Okay, wait. We'll do that later. Whatever. Cool. Okay, so let's start with properties. So, properties are used to describe the characteristics of objects or prims within an OpenUSD scene. Prims can have two types of properties, attributes and relationships. Attributes store data value that define the appearance and or behavior or other characteristics of the prim. Relationships, on the other hand, establish connection between prims or properties, enabling hierarchical structure and data sharing. Pretty straightforward. In the following lessons, we'll take a closer look to two types of properties, attributes and relationships. Let's go to attributes.
Hmm.
What is an attribute? Cool. We have our video. I love these. Wait, I didn't understand that. One specific data type.
Oh, it's vector, I think.
No, each attribute has one specific data type. So it could be a number or text or a vector.
Hmm.
Yeah. Oh,
often referred to as key value pairs, that store data associated with a prim. Each
Mm-hmm.
attribute is defined with the type of data that it can hold. Attributes can represent various types of properties, such as the vertices of a piece of geometry, the diffuse color of a material, or the mass of an object. Some common examples of attributes include visibility. This attribute controls the visibility of a prim in the scene. Display color. This specifies the display color applied to a geometric prim. Extent. This attribute defines the boundaries of a geometric prim. Attributes can be authored and stored within USD layers, which are files that describe different aspects of a scene. When a USD stage is composed, the attribute values from various layers are combined according to specific composition rules, allowing for flexible scene assembly. Attributes can be animated by providing multiple keyframed values over time. USD's time sampling model ensures efficient storage and interpretation of animated data. To work with attributes in USD, we'll generally use schema-specific APIs. Each schema-specific API has a function to grab its own attributes. For example, we can use this function to get the radius value of sphere underscore prim that is of type USD geom.sphere. And another example of setting the double-sided property of the prim would look like this. While there's also a dedicated USD attribute API in general, it's preferred to use the schema-specific methods if they exist, as they are more clear and less brittle. In this lesson, we learned attributes are values with a name and data type that define the properties of prims in a USD scene. Attributes are the primary means of storing data in USD. Each attribute has a single defined data type. Attributes are authored and stored within USD layers, enabling efficient scene composition. Attributes can be animated by providing keyframed values over time. They can be queried, modified, and animated using the USD API. Understanding attributes is essential for creating rich and detailed 3D scenes, enabling efficient collaboration and interoperability across various tools and pipelines. Thank you for watching, and for more information, please visit the official piece of geometry the visibility boundaries. This attributes the diffuse color of a material, present various types of property, or the mass of an object. Some common examples of attributes include visibility. This attribute, display color. This specifies the display
Okay,
color
they can
applied to
also
a
have
defined
visibility or
piece
something,
of
right?
geometry.
Extent. What is
Attributes can
this?
be
Is this
authored and
something
stored.
different? Extent, or is this just a type of attribute that we can get?
This is one of the attributes that you can attach to a prim.
Oh, I see.
So it's going basically what he's saying is there are going to be multiple attributes associated with a single prim. So something would be a display color, something would be visibility, and then extent.
Attribute defines the boundaries of a geometric prim. Attributes can be authored and stored within USD layers, which are files that describe different aspects of a scene.
USD layers, which define different aspects of a scene.
Hmm. Oh.
So basically every layer of that USDA file will have a different attribute for that particular prim.
Hmm.
When a USD stage is composed, the attribute values from various layers are combined according to specific composition rules, allowing for flexible scene assembly. Attributes can be animated by providing multiple keyframed values over time. USD's time sampling model ensures efficient storage and interpretation of animated data. To work with attributes in USD, we'll generally use schema-specific APIs. Each schema-specific API has a function to grab its own attributes. To grab its schema
Hmm.
specific. To work with
Wait,
attributes in USD, we'll generally use schema-specific APIs. Each schema-specific API has a function to grab its own attributes. For example, we can use this function to get the ratio.
what is schema specific API? I'm not understanding that.
I think if we go down, we will be able to understand it much better.
Specialized set of high-level commands tailored to a particular type of object, like a sphere, cube, or light. Instead of using generic raw commands that work on any object, these API provides shortcuts that understand the specific properties that belong to that object.
Highest value of sphere underscore prim that is of type USD geom.sphere. And another example of setting the double-sided property of the double sample of and
Okay,
another
okay. This is how we can
USD
set the
geom.us
attribute.
that is underscore
Oh,
value of
the
sphere.
radius
For
of the
example,
sphere. Oh, this, so this is one of the
each
API
schema-specific
that you can
API
use.
has a function to grab its own attributes.
Get
For
radius
example,
attribute
we can
dot
use
get
this function to get the
get
radius
double
value of
side
sphere
attribute
underscore
dot
prim
set true.
that is of
I
type
know.
USD geom.sphere. And another example of setting the double-sided property of the prim that looks like this. While there's also a dedicated USD attribute API in general, it's preferred to use the schema-specific methods if they exist, as they are more clear and less brittle. In this lesson, we learned attributes are values with a name and data type that define the properties of prims in a USD scene. Attributes are the primary means of storing data in USD. Each attribute has a single defined data type.
Mhm.
Attributes are authored and stored within USD layers, enabling efficient scene composition. Attributes can be animated by providing keyframed values over time. They can be queried, modified, and animated using the USD API.
Okay. So attributes are most common types of properties that you'll work with when creating scenes. An attribute can have one specific data type such as number blah blah blah. Each attribute can have default values and it can also have different values at different point in time.
That are called time samples.
Hmm. Okay.
Okay, so I think attributes, how does it work? So attributes are name value pairs, often referred to as key value pairs that store data associated with a prime. I think more likely like a dictionary
Yeah.
key value pair we have,
Hmm.
right? Any given attribute has a single defined data type associated with it. Each attribute is defined with the type of data that it can hold. A single attribute can represent various type of properties such as vertices of a piece geometry, the diffuse color of a material, or the mass of an object. The same thing that we just saw in the video. Some of the common attributes include visibility, display color, and extent. So over here, the visibility, it controls the visibility of a frame in the scene. Display color, it specifies the display color applied to a geometric frame. Extent defines the boundaries of a geometric frame. Moving on, I think attributes can be authored and stored within the USDA layers, which are files that describe different aspects of scene. When a USD stage is composed, the attribute value from various layers are combined according to specific composition rules, allowing the flexible scene assembly. Attributes can be animated by providing multiple keyframe values over time. OpenUSD's time sampling model ensures efficient storage and interpretation of animated data. We will learn more about time samples in time code and time samples lesson.
Hmm. Wait.
But we got to understand what like what is the data type that attribute use, that is dictionary, and the other one of the important thing is that they are typically defined through SDF library, right? What
Hmm.
was the full form? SDF, scene description
Framework.
framework. Yeah, yeah, scene description framework. And we can, like, I think we do remember like in our last extreme, we try to create a sphere. So in that sphere or a cube, we can definitely provide an attribute that, hey, should that sphere be visible? What is the display color of that sphere? And maybe any boundaries, boundaries that we might want to define. And the other thing is attributes can be authored and stored within the USD layers. That is like that is over there as well. So which are Hmm.
Okay. Each attribute is defined with the type of data it can hold.
Yeah.
A single attribute can represent various types of properties such as vertices of a piece of geometry, diffuse color of the material, and mass of the object. These are typically defined through SDF. Some common examples of attribute look like visibility, display color, extent. Attributes can be authored and stored within USD layers, which are files that describe different aspects of the scene. When a USD stage is composed, the attribute values from various layers are combined according to specific composition rules. When a USD stage is composed, the attribute value from various layers are combined according to specific composition rules. Process of combining multiple layers and scene graph elements together and creating a final composed scene. Allowing for flexible scene assembly. Attributes can be animated by providing multiple keyframe values over time. OpenUSD's time sampling model ensures efficient storage and interpretation of animated data. An animated value is data that can change over time rather than having a single fixed value. Example, time samples or animation splints. Attribute can be animated by providing multiple keyframed values over time. OpenUSD's time sampling model ensures efficient storage and interpretation of animated data. We will learn, okay. Cool, working with Python. To work with attributes in OpenUSD, we will generally use schema-specific APIs again. Okay. Okay. Got it. Bro, read this.
Working with Python. Dude, can you send me this link? I'm trying to open it on a different tab in my split view window.
Yeah.
where we are
We're at working with Python.
working with Python.
Schema specific APIs. Read
Mhm.
this.
So to work with attribute in OpenUSD, we generally use schema specific API. Each schema specific API has a function to grab its own attribute. Okay, so we have a sphere prim, and then we can use get radius attribute to dot get to get its radius, I think. And so while there is no there's also a dedicated USD attribute. Okay. Mhm. And then we have the get double-sided attribute that gets our double-sided property of the prim set to true. Okay, and all right. Let me open up the USD documentation. Okay, this looks pretty interesting. Whew, damn. USD attribute API and generate. Okay, so while there is also dedicated USD attribute API in general. So apart from this get radius attribute, I think we also have a specific lab API that is meant only for getting the attributes and other things. And then we have, if you click on the documentation, it will redirect us to the USD documentation page where we can see a lot of classes and
Okay.
other things.
Yeah. What does this do?
I think this is basically like it says what it does over there. Like file contains classes to facilitate network creation in unit.
Oh
This
my god. Yeah, yeah.
yeah, it's over there. And if we click on it, oh, we can get a more in detail information about. Oh, okay, hold on. This thing is completely based on C++. See, like if you open up any system functions,
Yeah.
yeah, it is using C++, and we have void, bool, uint64, and other things. Hmm.
Mhm.
Okay, it's fine. Yeah, let's now move on to the other examples. Scroll down.
One second. I mean, we should- each schema specific API has function to grab its own attributes. Okay. Get the radius value of sphere prim. That is the type of USD geom dot sphere. So every schema specific API has a function to grab its own attributes. Okay. So this is this own function to grab its radius attribute, right?
Yeah,
And then like get double-sided attribute, set the double-sided property. Okay. So this is already defined in the mm, what is it called? Generic API.
yeah. But we also
You
have something else like such a USD attribute API in general.
uh
Like so there are two ways, right? I think based on this, what I'm understanding is either you can use its own attribute specific schema specific API, or
hmm
you can use the USD attribute API in general. That will basically give you access to most of the things that
hmm
exist over there.
hmm Okay. Retrieving properties of a prim. Come on.
Oh, I thought you were trying to take a look at the how to run locally.
Mhm.
All right. So example one, let's look at how we can retrieve the properties of a prem. So properties are the other kind of namespace object in OpenUSD, whereas the prims provide the organization and indexing for a composed scene. Properties contain the real data over here. And then there are two types of properties: attributes and relationships.
Mhm.
To retrieve the property of a prim, we would use get properties.
Method, yeah.
And then for this demonstration, we will be using get property names. Instead, to retrieve the names of the property, this will not grab the property themselves, but a list of properties. I see. We can use get property to retrieve the properties themselves. Hmm. So now over here in the code base, we can see that okay, the first two lines are simple. The fifth line that says stage, it is basically creating a new stage file, and then we have USD geom.xform creating a geometric xform over here, starting with world. And then on the 10th line, we are defining the sphere with the sphere and then appending it in our original stage. And then same for the cube. And on the 14th line, I think we have something different. Over here, we are using the set translate API to create some kind of vector 3D definitions. I don't know what this is.
Hmm.
Let's take a look. Let me take a look. What is it? USD geom.xform common API cube dot set translate. Okay, let me yeah, I can. Explain the back 3D. Whew. And then we have the get property names of the cube prim. Okay, all right, I see. So let me take a look at first what this gf dot vec3d means. I can English. Dude, what the hell is Focus to doing?
I'm telling you, bro.
The end game is here, right? End game.
Perplexity is not it.
So in English, gf.vec3d means a vector with a three double precision values. In set translate gf.vec3d 5000, it represents a translation of 5 units on the x-axis, 0 on y, and 0 on z. So it's a three component vector where each component is a double, and the D in the vector 3D stands for double basically. Damn, I don't know about that. Oh shit. So basically, GeoVec 3D is a 3D vector component that in which we can pass on double integer values rather than a single integer. That's what it's saying. And now, if we take a look at our output, what do we get? So what are we getting? We are getting double-sided extend orientation. Okay. So once we use cube prop names and use cube.getPrime.get properties, and just try to do a for loop, we are getting all the properties that the cube prop has. So we have double-sided extent, orientation, prime vars, proxy prim, purpose, size, visibility, xpom translate, and xpom operation order. Now I'm just confused on how are we getting all these properties in this. Okay, all right. So we have cube. Hmm. Okay, so I think this simple single API call that we made to do the set translate and then do the gf.vector3d, it loaded
Mm.
our cube with all these properties that are listed below. That is double-sided means I don't know what this. Okay, what do each of these property means and how are they loaded? Okay, so there are some built properties. that you get with USD geom.cube, and all the properties that we get from USD geom.cube are double-sided, extent. So what is
Bro,
double-sided?
wait. Share your screen on FaceTime. I'll put it on the stream.
I think it's gonna do. You know what? I know what it will do. It's fine. Got it?
Yeah.
Yeah.
hmm Why am I hearing my voices?
Wait. Now say.
Uh huh.
Uh-huh. Oh,
Yeah,
yeah,
it's
it's all
fine.
good. Yeah, it's fine. Okay.
Yeah.
Yeah. So as we can see over here, each and every property defines something.
hmm
Mm-hmm. So the double-sided property that we just saw from our cube, it says that a boolean on a geometric prim that says whether the surface should be treated as double-sided when rendered or shaded. So it's a schema fallback. I see. So the first property defines if our cube should be double-sided when rendered or shaded.
Okay.
Okay. Wait, let me take a look on what is double-sided or means. Are you able to see my screen, right?
Yeah, yeah.
Yeah. Okay. The okay. Volume or render volume. No, 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 no. Okay, over here is a double-sided. Yes. So over here, the double-sided is I think has type bool and the fallback value as false, and this is for geometric prim, G prim. That is a defined property that it has. And let me go back over here and let me ask it directly. Explain all the properties to a 10-year-old. This would be much better.
Wait, I have
Wait, I have
an
an
explanation ready as
explanation
well.
ready as well. Okay, yeah, over here we got it. So double-sided. This should the cube be visible from both sides, like paper? You can see front and back through the game camera, or just one side. Oh, I see. I see now. That's what it means. So we have a thing. Should the cube be visible from both sides, like a paper? You can see front and back.
Mm.
Oh, okay. And so this property is a bool value. So like if you make it false, right, then only one side would be rendered of the cube. And if you make it true, then both sides will be rendered. As we can see in the documentation over here, it says that it has a bool value and the fallback is by default false. So if you don't define anything in that double-sided property, it's going to default to a single-sided value only. If you define it as true, then it's going to render a double-sided. And now let's move on to other properties we have. Then we have extent. So the cube space box, meaning the smallest box that contains the whole cube in the lesson. The default cube goes from -111 to 111. What is this? Ooh, damn.
Oh,
Oh,
front and back,
front and back,
double sided.
double-sided. Double-sided. Like okay. Oh damn! Wait, dude, you saw this? Ooh,
Yeah.
wow. Yeah. Whoa, 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 whoa! Damn. Okay, that's fine. Okay, and then we have what? Orientation. The rule for which way the cube surface point are ordered, which helps the computer know what counts as the front side. So this orientation means this property defines okay which way the cube should be pointed, and the system knows which is front side. In a
Mm-hmm.
scenario where rendering maybe a house or something, then we can
Mm-hmm.
define that complete house if in the file or that cube property as based on the orientation. That's what it's saying. And then what the next we have is prime where display color. So this is like really simple. I think this says that the color the cube should look like in the viewer such as green in the example after it gets set.
Mm-hmm.
And then we have the opacity as well. So how we see through the solid. So if we have higher opacity, then I think we won't be able to see shit.
Bro, opacity
Bro,
would be
opacity
true
would
or
be
false. It
true or
would be
false.
like a
It would be like a
Boolean
Boolean
value.
value.
It is not
It is not
high or low.
high or low.
It's true or
It's
false
true or
Yeah.
false
opacity.
opacity.
Yeah,
Yeah,
I think it
I
should
think
be.
it should be.
Yeah, let me take a look. How what is display opacity data types? Is it boolean or high low?
No
See,
float.
No float.
I told you, bro, it's gonna be float.
Okay.
Okay.
See through.
See
Okay.
through. Okay.
So because this is a similar kind of thing we do have in our front end, right?
Yeah, yeah, yeah.
When we define an object, right, and we can define okay what is a percentage of opacity that object can
Mm-hmm.
have, or that the component can have in the
Mm-hmm.
background, and then we can do 60%, 70% like that. So the
Mm-hmm.
same thing applies over here, I think, and
Mm-hmm.
that's how I derived that. Okay, it should be high or low in the manner.
Mm-hmm.
Then what do we have next? We have proxy prim, a
Okay.
link a link to a simpler stand in the version of an object, kind of like a rough sketch instead of the full detailed model. I don't know that. Like let's see.
Can you scroll up
Can
a
you
little
scroll
bit
up
on
a
the
little bit on
page?
the page?
Yeah.
Yeah.
This
Yeah. More.
Yeah. More.
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 What does it say
What does
over
it
here?
say
Get
over here?
properties
Get
method
properties
for this
method for
demonstration
this
will use.
demonstration will
Okay.
use. Okay.
Okay.
so if we
Okay.
use if so since we over here as we can see we use names.
Yeah.
Yeah.
It's loading all those things. Like it's an array. So when we use get property name, it's gonna return an array, and then we
Mm-hmm.
just iterate through the array.
Mm-hmm.
That's what it says. But I don't know. Let me explain proxy prim. In more elaborate manner. So proxy prim is a relationship, not a regular number or a text value. It connects a heavy real render object to a lighter stand-in object. For faster preview work in USD, it is meant to link a prim whose purpose is to render to another prim whose purpose is to proxy. What it means, imagine you have a super detailed car model with millions of polygons. Instead of drawing that full car while you move around the scene, USD can point to a simpler, low detail version that and
Oh,
that simpler
is the
version
proxy
is the
prim.
proxy prim.
Yeah.
Yeah, I see, I see. So basically, we are
To
not trying to. So yeah, so basically, if you have really complex prim, in that scenario, we will use proxy prim to basically render a small component and to see
mm-hmm.
how it is interacting with other prims.
Mm-hmm.
So proxy prim is basically saying when you need a cheap preview of this complicated thing, like basically running npm run dev in our front end
Mm-hmm.
to render things, even though all of the components won't render properly, right? But we will be able to see the functionality, right? So I think that's where proxy prim is used mostly, and
Mm-hmm.
why it exists. This is useful for interactive tools, DCC apps, and pipelines that want fast playback and easy selection without loading or drawing the full detailed assets all the time.
Yeah.
Yeah. I see.
Okay.
Now, what do we have next is the purpose. What is purpose? So, tells the USG object what is meant for. Like, show this for rendering or use this as a simple preview. I think that's more of a textual value uh, or string for its data type. And the size next. How big is the cube? Yeah, this is really simple. Defining the size. That's a simple property. Then the visibility, whether the cube is shown or hidden. Then we have the X form operation translate property. The move instruction here, it says move the cube 500, which means 5 steps on X direction.
Yeah.
Yeah. I think this is what it is doing, right? So I think this is our initiation point, and then we
Mm-hmm.
are moving 1, 2, 3, 4, 5. And
Mm-hmm.
our 0, 0 means that, okay, the 0, 0 means we are on the same axis as our
Mm-hmm.
sphere, right? So that's why it's not like, merging. Both of them are
Yeah.
not merging the same. They are trying to stay away from
Mm-hmm.
each other at this point. And then we have operation order. The order to follow when applying move, rotate, scale instruction. In this example, it contains just XForm translate. Let me take a look if we are using XForm translate over here or not.
Can you show me the
Can you show
code,
me the
initial
code,
code
initial
for
code
this?
for this? Yeah, this is the initial code.
Yeah. Bold
Yeah,
X form,
bold
USD
XForm,
geom dot
USD
X
geom dot
form,
XForm,
USD geom X
USD
form
geom
define
XForm define
stage. Yeah. Can you
stage. Yeah,
scroll
can you scroll
to the right
to
a
the
little
right
bit?
a little bit?
No,
All
to the
right.
right.
No, to the right.
Yeah.
Yeah. I got you.
Okay. Yeah.
Okay.
Go back.
Yeah, go
Go
back.
back.
Go back.
Define sphere under
Define
the
sphere under
word,
the
sphere blah
word,
blah
sphere
blah,
blah blah
USD
blah,
geom
USD
define
geom define
stage, and then
stage,
bold
and
X
then bold
form.
X form.
Define cube under the
Define
bold
cube
X
under the
form, set
bold
it
X
to
form,
5
set it to
units
5 units
away. Yeah, this
away.
is the
Yeah,
code,
this
right,
is the
for the
code,
X
right, for the
axis.
x-axis. Yeah. So I think your x-axis is getting defined with using XForm common API. We are wrapping our cube into XForm common API, and then we are using the set translate to create the translation.
Mm-hmm.
That's how it's going right now, right? Let me just ask him how this. Why are we wrapping? Explain.
Can you scroll to the
Can you
right
scroll to
one
the
more
right
time?
one more time?
Over here, yeah.
Over here, yeah.
World X
World X
form dot get
form dot
path
get
append
path
path
append
here,
path
okay,
here,
and
okay,
then over
and then
here
over
it's
here
cube
it's
dot
cube
define
dot define
stage comma
stage
world X
comma world X
form get
form
path
get
append
path
path
append path
cube, okay.
cube, okay.
Oh, it's
Oh, it.
so what is that
So what
GF
is
dot
that
vec
GF dot
3D?
vec
Is that
3D?
like
Is that
a
like a
specific schema
specific
API as
schema
well?
API as well? Yeah, that's a specific schema API that renders in three-dimensional with three axis with
Mm-hmm.
D means double. That's what it
Uh,
says, and this is mentioned over here as well.
okay.
Okay. Right. Okay. Right. So XForm is the instruction list that tells USD which transform step exist and in which order to apply them. In our example, set translate, it creates a translate transform operation, and the file stores that as an XForm translate.
Mm-hmm.
While the XForm operation order stores XForm translate to say apply transition, that is the only transform step on this cube. Okay. So it says that when we call this whole thing, USD authors a translation attribute on the cube with value this one, and then it gets saved. So I think this is really a complex way to create such
Mm-hmm.
kind of translation. I think if we once we go more deeper into this, we might be able to understand more about the XForm Common API and its use cases.
Mm-hmm.
Mhm. The most important thing is the order. If the order is not correct, then it won't be able to, move and then rotate. So let me take a look over here. Okay, move and then rotate. Oh, wait. If you don't touch it, it's doing something, right?
Mm-hmm.
Mm-hmm. Let's see. Let's wait. No, it's not doing anything. Okay. Yeah, so I think this sums up our X form, our properties that we have used in this code base, like while rendering the whole thing. So we have used double-sided for rendering both the sides of the cube. Then we have used extend to create an extension of our trim. And then we have used orientation to make sure that what is the default orientation, like where will it face for the user, what is the front side, what is the back side. Then we have our color. Since we did not define any color, it's going to be pure white. The opacity is going to be high for now. And then we have a proxy trim that renders everything in a manner that we are able to see what we want to render, what we are trying to render, and as well as other complex components without loading everything,
Mm-hmm.
right? And then we have purpose, like that, basically a tag that tells what the premise about, what is the object about. And then we
Yeah.
have the size. And then we have the visibility that showcases that is it visible, is it hidden. And then we have the xform operation translate that translate, okay, on which axis are we trying to translate it. Is it x, is it y, or is
Mm-hmm.
it z? And then we have the order. So our xform operation order is the most important thing over here. They are focusing over on that because it defines the way how the translation is going to occur. For example, let's say you're rendering and you want to first move the object. So you will order the operation in the same manner, I would say.
Yeah.
Yeah.
Mm-hmm.
Let's move on to our next example then. Getting attribute values. So attributes are the most common type of property authored in most USD scenes. An example of simple attributes that describes the radius of the sphere. So we have our sphere, and then we have defined it, and then we have our double radius equal to 10. So this is really simple attribute we interact with. Again, it says that we can interact
Mm-hmm.
with attribute using the USD attributes API over here. Let's go through some of the members of the core metadata that we have over here. Let's see what we can find. Okay, as we can see over here, we can get with the some of the attribute properties that exist are, I think, SDF variability, get variability, and attribute variability expresses whether it is intended to have time sample or cleanliness.
Lines. Okay,
Okay,
wait.
let's
Pause.
look for some simple. Oh yeah, oh we have some simple attributes as well.
1 second.
One second.
Give me one
Give me one
second.
second.
Oh,
Ah,
need
need
hydration.
hydration.
Okay.
Okay. Okay. Uh,
Where were we?
Where were we? So we were taking a look at the USD attribute API
Mm-hmm.
and its classes and its functions that we get. So we have get color space, gets the color space in which attribute is authored. Now each prim type has their own set of properties and corresponding functions to retrieve them. Since our sphere is of type USD geom.sphere, we can use a schema specific API to get and set the attributes.
Mm-hmm.
Huh.
Yeah, that's
Yeah,
what we
that's
were
what
talking
we were
about.
talking
Get
about.
radius
Get radius
attribute
attribute
method over there.
method over
The
there.
return
The return
USDA
USDA
USD attribute
USD
object that
attribute
can
object that can
be used to
be
modify the
used to modify the
attribute.
attribute.
Which means it will
Which
not
means it will not.
Okay. So it says that
confusing.
get radius attribute will return a USD attribute object that can be used to modify the attribute, which means it will not retrieve the value of the attribute. To get the value of the attribute, we need to use the get method.
Mm-hmm.
Oh, okay. So it was so what it says that I think over here they have used get attribute radius attribute, right? So when
Yeah,
we use this, it
we need
returned
to
an
We
append
object.
need
it
to
with
append it with
dot get.
dot get.
Yeah, not yeah, basically that. So why we have to do that? Because this returns an object,
Mm-hmm.
and in that object, to get the value of that object, like what does it
Yeah.
have? We have to use dot get
Mm-hmm.
to get the value.
Okay.
Okay.
So now, okay, and then is this the one where we are? This is the one, right? No, this is the one. Yeah, this is the one. Where we at? Holy shit. Okay, yeah. For example, to get the value of the radius attribute, we use this as discussed. Let's use get method for radius, display color, and extend attributes. So let's look at this example. We have world xform, USD geom.xform. We have like basically defined. We have first completed our staging, and then
Mm-hmm.
we have created sphere, cube, and then the same thing that we did over here. Now we are trying to get all the attributes. So we are using cube dot get prim dot get attributes
Yeah.
function basically to get all the attributes, and I think it returns an array. That's why we are trying to do a for loop into that. And over here we can also get the size, display color, and extent. For that we are trying to use USD dot attribute, and we are getting cube dot get size attribute. Okay, why do we need to do this? I'm trying to understand that. Why do we need to use USD dot attribute equal to cube dot get size ATR? Okay, no, but why do we need to define? Okay, what if we define just cube size as cube dot get size ATTR? Oh, I see now. Oh, okay, it's a type notation.
Wait, bro. Let
Wait,
me
bro. Let me
take over
take
now.
over now.
So it's saying that over here, Python expects this general shape for an annotated assignment. Oh, okay, yeah. Oh, it's really simple. So USD dot attribute is basically the type, And it's not necessarily that we define this type. If we do define this type, then it's a good coding practice. But the most important thing is using cube dot get size attribute to get your values. Right, it's gonna basically load the object onto this variable, and once we have the object on into this variable, we can use dot get to load our values. Basically, we can see over here when we do print, looking at the last three statement, we can see that size 2.0 was printed, display color none was printed with the get, and the extent was also printed like an array. And I think it's a 2D array over here. And moving on to this ones, so over here we have just printed what all the attributes that exist. So I think it has returned all the attributes of that prim that
Yeah,
will
that's
be
a for
inside the
loop.
cube.
So
Yeah, so
okay.
we have everything. So it's like it's gonna be like double-sided extent orientation. So we could also get the value of this attributes. What that's what I'm saying. If we say, for example, cube dot get double-sided attribute or something. Let's ask it. Okay, how to get this value?
Oh, so
Uh,
they basically want to do cube size type hint, then USD dot attribute equal to cube
yeah,
dot get double sided, and then
yeah,
parenthesis,
yeah.
and
So
then
it's
that's
gonna be
basically gonna print the.
yeah.
Yep, that's what it did. Get attribute double sided. Wait, why is it doing it differently here? Double sided underscore attribute dot get. Hmm.
Oh, I see. So again, we have two options. Either
Generic
we
API and
yeah,
schema specific
schema
API.
specific. So if you don't know about the schema specific, so I think
Okay, go down. I
what
think it. Yeah, yeah, yeah. Go down, go down, go down.
yeah.
Yeah,
Oh,
yeah.
I
See.
see. Yeah. Cube dot get double sided
Uh-huh.
attribute dot get. Yeah. Now it
Okay.
makes perfect sense. Now it makes perfect sense.
Okay. Can you scroll up a little bit? What else did I tell? So basically, just cube USD geom dot cube USD geom dot cube dot define USD geom dot xform API. How did they set the schema specific API? That's what I'm trying to understand. Like, how do
Because
we? Like, how would we
you
understand
understand.
when
So
do we
it's
need
all about
to use the schema specific API and when do we need to use the general API?
how do we
Choose.
know that when to use schema specific versus general.
Cube dot get size attribute. Okay, when you know you are working with USD geom dot cube or
So
another known schema
basically, if
type.
you
Yeah,
know,
but that's what I'm trying to understand. But how do we know if it's like a known schema type or not? How would we know?
so the thing is, we are, it depends on you. If you don't know, you can use a generic way, right, to get the attributes. But if you know, you can look into the documentation and update it. I think that's what this is a normal choice for app code such as blah blah blah. I want its size. I want the official. So use generic when use like when your code doesn't know the type in advance.
Hmm.
Oh, so like if you know what you're building, then you can basically use schema specific particularly. But if you don't know what
Yeah.
you're trying to build, or try just, I think it's more for debugging purpose,
Hmm.
right? Rather than maybe like going through the documentation and finding the schema specific API, just use
Yeah.
the generic one, and then you get the output accordingly.
Yeah.
Okay, now let's move. Setting it's like we use set to set the attribute, get radius attribute. Okay, so we are going to use the same schema specific. Okay, so I think one thing, let me ask, can we use get set on generic APIs? This would be a good question.
In last
In
example,
last
we
example,
use
we
get
use
method
get method
attribute to set the
attribute to set the
value,
value, set the method
value
value
to
to
radius,
radius.
get
Get okay, yeah. All right, makes sense. So this is really simple. We are using getters and setters method that we have in our programming to basically set the attribute for something. If even if you don't know the schema specific API, we can directly use USD generic API to get the object and then just set it accordingly over here, as we can see. Based on our last modification, blah blah blah. Over here, okay. Now we are basically setting our values using cube size.get. Once we have all the attributes, ooh, green and white, boom, baby.
can you show the
Can you
code
show
one
the code
second?
1 second? Over here.
Yeah,
Yeah, more.
okay,
Okay,
file tool
file
bold X
tool bold
form.
X form.
Whoa.
Whoa.
Okay, that's
Okay,
just
that's
defining the
just defining
stage.
the stage.
Sphere
Sphere
USD
look from
geom
USD
dot
geom dot
sphere.
sphere. So until 10, everything is same. Look from over here. 12.
Cube size
Cube
USD
size
attribute
USD
equals to
attribute
cube
equals to
dot
cube dot
get size
get
attribute.
size
What does that
attribute. What
line
does
do?
that line do? This one?
Yeah, size.
Yeah,
It defines
size.
the
It defines
size.
the size. It gets the object of the size attribute.
Okay.
Okay. And then this one sets it 18th.
Mm-hmm.
Mm-hmm.
Cube size
Cube
USD
size USD
attribute equals to
attribute
cube
equals to
size
cube size
attribute. Cube
attribute.
display
Cube
color
display
USD
color USD
attribute. Get
attribute.
display
Get
color
display color
attribute.
attribute.
Okay.
Okay.
So
So
cube
cube
extend USD
extend
dot
USD dot
attribute equals to
attribute
cube
equals to
dot get
cube dot
extend
get extend
attribute.
attribute.
Cube
Cube
extend
extend
USD dot
USD dot
attribute equals
attribute
to.
equals to. And I think this is an RGB preference set.
Mm-hmm.
That's why it's not saying green. We have to use RGB color coding pattern.
Mm-hmm.
Let me just verify. Okay, is the above an RGB color pattern? Yes, as we can see, it's definitely an RGB color style.
Yeah, I
Yeah,
know
yeah, yeah.
that.
I know that.
That's why
That's
G
why
is one,
G
that's
is
why it's
one. That's why
green.
it's green. Yeah, as we can see, we have all the properties that exist over here: the size, the translate value, uniform token operation order,
Mm-hmm.
and then the float extent. Oh, we are almost done. What are the key takeaways, guys? The key
Yeah.
takeaways are: whoa, attributes are values with a name and data type that define the properties of prims in a USDC. Attributes are the primary means of storing data in USD. Each attribute has a single defined data type. As we can see over here, each attribute has a single defined data type.
Mm-hmm.
RH float, double, uniform, double three.
What is
And then
color
what is color
3F?
3F? Color 3F, it says over here. Where is
Oh,
it?
that's a
Oh,
data
that's
type
a
for
data type for
colors.
colors. Yeah. Yeah, where each color is a 3-number tuple.
Oh,
Oh,
tuple. Okay.
tuple, okay. And then attributes are authored and stored within USD layers, so we know what we use for authoring. Tell. This is gonna be in the quiz. What do we use for authoring?
What were you saying?
What were you saying? What do we use for authoring? What property do we use for authoring? How do we author?
Attributes are authored
Are
and stored
authored and
within
stored
USD
within USD
layers,
layers,
enabling
enabling
efficiency in
efficiency in
compositions. Are
compositions.
authored
Are authored
are
are.
so what
So
you're
what
asking
you're asking?
what
What
authors
author's
attributes?
attributes? No, what is the property?
What is the
What is
property?
the property? Yeah, what is the property name that we use for authoring? Like if you want to author this prim,
Yeah,
yeah, what property is used?
I don't know.
I don't know. It's gonna be the purpose property over here.
What?
What? Yeah, bro. Wait. Where is it? This one. Purpose. I can show you over here. Wait. X form. Over here. Token purpose render.
Okay,
Okay. Let me go a bit more up. I think we're gonna find it over here. Go.
that's fine,
That's
bro.
fine,
Let
bro.
me.
No. We are over here. Tells USD what object is meant for. Like shows this for rendering or use this as a simple preview.
Hmm.
Hmm. And then we have attributes can be animated by providing keyframe over time.
Mm-hmm.
And they can be queried, modified, and animated using USD API.
Mm-hmm.
Understanding attributes is essential for creating rich and detailed 3D scenes, enabling efficient collaboration and interoperability across various tools and pipelines.
Mm-hmm.
I think we can focus on the quiz.
Yeah.
Yeah.
I'm a
I'm a
little
little
skeptical about the
skeptical
code
about the
part
core
that
part
we
that
did.
we did. What are you skeptical about?
Mm,
Mm,
let me see.
Let me see. If you want, you can take over. Let me start
Yeah,
sharing. Yeah.
I can take
I can
over.
take over.
GF 3D
GF
vec
3D vec
setting
setting
attribute
attribute
values.
values.
Yeah, let it
Yeah,
be.
let
We
it be.
can do
We
the
can do
quiz
the quiz
just for
just for
attributes, right?
attributes, right? Yeah.
Hard, right?
Hard, right? Hmm?
More and
More
hard.
and hard. Yeah, more and hard. That will work.
Oh. Waiting for the
Waiting for the
moment is
moment
now or
is
never.
now or never.
You start a startup. If you start a startup without a good idea, and you just kind of cast around for one, you'll be under pressure to make something up. It won't work that well. The very best startups are all started because someone believes so passionately in an idea, and they believe that a startup is the best way to make that happen.
Dude, what's happening is, why is it not generating the quiz out?
I don't know.
I don't know.
Let me
Let
reload.
me reload. Attributes were pretty easy, I would say.
Yeah.
Yeah.
Okay.
Okay.
We have it.
We have it. Oh,
What's going on?
what's
Why is
going
it
on? Why is it
dark?
dark?
Okay.
Okay.
Which specific
Which
library in
specific library in
OpenUSD is
OpenUSD
typically
is typically
responsible for defining the
responsible for
various
defining the
data
various
types
data types
that a single
that a
attribute
single
can
attribute
represent,
can
such as
represent,
vectors
such
or
as vectors or
integers?
integers?
USD Geom.
USD
Oh
Geom.
no,
Oh no,
SDF, like
SDF, like. Wait, which specific library?
I think it's
I think it's
SDF library.
SDF library. Yes, it's gonna be. I think it's SDF.
Yeah,
Yeah,
that's right.
that's right.
In the context of
In the context of
OpenUSD properties,
OpenUSD
what
properties,
distinguishes
what
an attribute
distinguishes an
from a
attribute
relationship?
from a
Attributes
relationship?
store
Attributes
specific
store
data like
specific
number,
data
vectors,
like
or
number, vectors,
relations, or
or
connection
relations, or
between
connection between
objects.
objects.
Yeah,
Yeah, that was good.
very.
Very.
When using the
When using
OpenUSD
the
Python
OpenUSD
API,
Python API,
why is it
was it
generally
generally
preferred to use
preferred to use
schema-specific
schema-specific
methods like
methods
getRadius
like
attribute
getRadius
rather
attribute
than the
rather than the
generic user
generic
attribute API
user
that
attribute
are
API that
deprecated
are
now?
deprecated now?
More clear, less
More clear,
brittle than
less brittle than
B.
B. Which, when using OpenUSD Python, why is it generally preferred to use schema-specific methods like getRadius attribute rather than? Yeah. Wait. Oh yeah, I think it's gonna be. Boom. If
If
a
a user
user
calls get
calls get
method on an
method
attribute
on
that
an
has no
attribute that has no
authored values in
authored
any layer,
values in
what will
any layer, what
OpenUSD
will
return?
OpenUSD
The value of the
return? The
same
value of the
attribute from
same
the parent
attribute from the
prim.
parent prim.
Fallback value 0
Value
regardless
zero
of the data
regardless of the
type.
data type.
Tell bro.
Tell bro. Hmm. If a user calls the get method on an attribute that has no authored values in any layer, what will OpenUSD return? A value of zero, regardless of a fallback value defined in P. I think it should be D. Okay, think about it. Of the fallback value defined in the Prima scheme, I think it should be D. Based on.
If a
If a
user calls
user
get
calls get
method on
method
an
on an
attribute
attribute
that has
that
no
has
authored
no authored
values in
values
any
in
layer,
any layer,
what will
what will
open?
open?
Dude, the hell.
What happened?
What happened?
My system froze again. What the? Dude, I think it's dude FaceTime and video. This video ninja is messing my system up. M4 Pro Max down the drain. Shit.
Bro,
Bro,
M3 for the win. And I'm running OBS also.
Yo. Hello, 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 hello.
Ah,
Are you able to hear me?
yeah.
Yeah. So I think it should be deep, but
Oh, over here. 1 second.
yeah, dude, I can see it in the note. It says that attribute values will not show up in user. However, values are coming from fallback value defined in the sphere schema.
Yep.
There we go. Bam.
What is the
What is
primary difference between get properties and get property names method in OpenUSD API? Get properties and get property names.
it's gonna be B.
B.
Yeah, it's gonna be B.
I don't understand this question. What does get properties do actually? What it just lists all the properties of that attribute.
Yeah.
And the name?
Returns a list of strings. It says over there B.
List of string. Cool. Object. Okay, object themselves. Oh, okay. Get property name will return a list of strings, and get properties will return objects. Got it. How does OpenUSD handle animated data for attributes to ensure efficient storage and interpretation by restricting animation?
Okay, how does it handle animated data for attributes?
Oh, D. It's gonna be D.
Yeah, it's gonna be.
Boom, boom. An attribute in OpenUSD can be described by as a name value pair. Which of the following is a strict constraint on these pairs according to source material? Attribute values must be stored in the same file as prim organization. Attribute names must always match their data type name. Attribute cannot have default value if it has the time samples. Attribute cannot have a default value. Each attribute has exactly one defined data type. Tell bro.
A, I think it should be A.
Name which of the following is a strict constraint on these pairs according to the source? Oh.
Each attribute has exactly one defined. D can also be an answer because that is also one of the strict constraints we have. Each attribute has exactly one defined data type. D.
Uh-huh.
D can also be an answer. So I think we should go with D.
Consider the limitations on the value part of the key value pair. Attribute names must always match their data type name. You're saying D.
Yeah, I think we should go with D
Ooh, right.
because like I think in a lot of examples they were really focusing on that each attribute should have a data type and a single data type. Normally, each attribute cannot have multiple data type when you're defining them.
Mm-hmm. I see, I see. The text states that given attribute has a single defined data type. Each attribute has exactly one defined data type. Okay. Which of these identified as the most common type of property authored in most USD scenes? What?
Attributes. Wait. Oh,
Yeah. It was actually a straightforward question.
yeah, I think this was.
When a user authors a value using the set method in specific layer, how does this affect the get method results compared to the fallback value?
How does this affect the get method results compared to the.
Unless layer is baked, return an array containing both the authored value and the fallback. Get will resolve to the authored value instead of the fallback value. The set method permanently deletes the fallback value from the schema. Hmm. I don't know, bro.
I think it should be C. Like get will resolve. Wait. Yeah, get will resort to authored value instead of fallback value.
Fuck. Yeah, that's right.
Next. Which
Which
geometric
geometer? Yeah, read.
which geometric attribute is specifically responsible for defining bounding box or spatial limits of a
Extent.
frame?
Extent. Read.
If you look at .usd file and notice that no value is written for a sphere radius, but USD view shows the value resolution of a fallback value.
Yeah.
No, false.
A single attribute can store both a piece of text and a value. False. Yep. In OpenUSD hierarchy, what is the conceptual relationship between prims and properties? Prims can provide organization and indexing where properties contained in the real data.
Mm,
Uh, while properties represent starting value. No, A. It's gonna be A.
hmm.
What does the method getRadius attribute get return in the USD geom button list of attributes? Yeah, B, I think.
Which what does method get radius attribute uh, a USD attribute object? See,
Mm,
if you don't set dot get, it won't return that thing. You
Yeah,
have to.
yeah. It's object.
Yeah.
Correct. Text graph is okay. Which of the following is not listed in the source as a common example of an attribute? Composition arcs.
No,
Easy.
nice.
When a USD stage is composed, what determines the final value of attributes if they are authored in multiple layers? Composition rules, uh, specific composition rules. A.
When I use component.
I think it's gonna be A.
When a USD stage is composed, what determines the final value of attribute if they are authored in multiple layers?
Bro, A.
I think. Are you sure it's gonna be A?
Yep.
Could it be C, the data types complexity?
No. No way.
Okay, yeah, let's go with A.
Yes, sir. If you wish to modify the value of an attribute such as display color, which method would you should you choose on USD attribute object? The update method.
If you modify that,
Set or update?
it should be set. I don't know. I haven't like when we were going through the documentations, I did not saw the update method defined. It's usually
Hmm.
set.
Hmm. According to the source, why are attributes essential for collaboration across various tools and pipelines? Uh,
According to source, why are attribute essential for collaboration across various tools? B.
yeah. What does USD geom sphere schema define as fallback for? The radius, if it isn't specified, the value author derived from external and value using a value defined within the sphere schema.
Tricky, I think.
I think it's gonna be C.
Wait, it says if it isn't specifically authored. So could it be a value derived from the external attribute? Do you think could it be that?
Value derived from extend. No, bro. Extend attribute is just for spatial positioning and all that stuff. Vectors and spatial positioning.
Okay. Go with
I
A.
think it's
Oh,
gonna
sorry,
be
go
C.
with C. You say so. Oh,
Yes.
next.
Time sample different values of an attribute. Yeah, C.
Yeah.
Boom, boom. Done.
And we have 20 on
100,
20.
100%. Because attribute was very easy, bro. I think.
Yeah. Granted, also I slept in the evening, like I slept for 2 hours. More 2 hours.
Oh, I see. Yeah, we can take a look at the research paper a little bit. There are like two research papers that needs our attention. One is EgoScale and one is World Attention Model, but World Action Model. But we're just gonna do World Action Model today,
Mhm.
and we already did the abstract. Ooh, cool. Okay. I've generated a video as well for this research paper for us to see. And we have some flashcards.
Mhm.
Future states. 14 million. Zero showed an improvement of over dash in generalization compared to state of the art at 2x. Okay, read it, bro.
Recent robotic foundation model termed vision language action models VLAs extend pre-trained VLMs, that is vision language. Wait. Okay, recent robotic foundation models termed VLAs, that are visual language action models, extends pre-trained visual language models to predict more actions, while
Motor
VLAs
actions, bro. Motor actions.
while VLAs successfully inherit linguistics prior to generalize across diverse language instructions, especially manipulating diverse objects. Their generalization to novel environments and more critical to new notions or skills remain limited. For example, VLAs can successfully execute more move coke can to Taylor Swift location and connecting it to a learned move skill from the robot. However, they fail at a task like you untie the shoelace if that specific skill was not present in the robot training data. Although VLM prior encode awareness aligned with geometric dynamics and motor control, as a result, VLAs often struggle to adapt to new environments
Bro,
or
you skipped the line.
which line, dude?
You read right. by,
Dude,
lev-
I don't know, man. Wait.
by
Okay.
leveraging web knowledge acquired during VLM pre-training to identify the target location and connecting to the learned move skill
But
from robot data. However, they fail at a task like untie shoelace if the
specific
specific
skill
skill was not present in the robot training data. Although VLM priors encode what to do at semantic level, they lack representation of how action should be executed with precise spatial awareness aligned with geometry dynamics and motor control. They lack representations of how action should be executed. Okay. As a result, VLAs often struggle to adapt to new environments to generalize novel tasks beyond distribution of expert demonstration without explicitly collecting large-scale task and environment-specific action data. Hmm. So this is just explaining the fallbacks of or drawbacks of VLAs. Okay, you can start reading from here.
So in this paper, we present Dream Zero, a 14 billion parameter model, robot foundation model built upon a, a pre-trained image to video diffusion backbone. We term this architecture a world action model WAM, WAM, a foundation model designed to predict both actions and visual future states in an aligned manner. Initialized from video diffusion models trained on web scale video data, WAMs leverage rich spatiotemporal prior to jointly jointly generate future frames and action condition on language, instructions, and observation. This shifts action learning from dense state action imitation into inverse dynamics.
Two inverse dynamics.
Dynamics aligning motor commands with predicted visual futures.
Yeah.
Consequently, we observe that this enables effective learning from robot that are heterogeneous trajectories collected during the execution of useful behavior in real world settings, rather than relying solely on carefully repeated demonstrations. Zero shot generalization to a new task in new environments, and efficient cross embodiment transfer.
I think we need to understand this
Yeah,
perfectly.
definitely.
Oh. Oh.
What does it say?
One second. My eyes are too dry, bro. Oh my god. Give me 2 minutes, bro.
Mhm.
Oh, my eyes are hurting. Okay. Researchers are highlighting how the model breaks away from traditional robot school limitations. Here is the breakdown of these 3 points in skills. Although traditionally, to teach a robot to pick up a cup, you'd have to show it the exact same motion hundreds of times in clean lab. This is a this is called repeated demonstrations. Dream Zero way. It can learn from heterogeneous trajectories, basically random messy recordings of robots just doing useful things in real world, like robot moving around a kitchen or a supermarket. It doesn't need to see the same task over and over to get it. It learns the general rules of physics just by watching diverse movements. Zero shot generalization the old way. If you taught a robot to pick up an apple in a kitchen, it would likely fail. Hmm, Specifically trained to do. Never been done before. Because it has a deep common sense understanding of how objects move thanks to that video diffusion backbone. It can look at new tasks like untying a shoelace and imagine how to do it successfully on the first try.
Okay. The old way, if you taught a robot to pick up.
Got it. It can basically get trained on web scale data, and then it can perform zero shot generalization, and then it can also do cross embodiment transfer, which is like the same brain can get calibrated to a new body in under 30 minutes to perform all the same tasks that the prior body was able to do.
Mm-hmm.
So, okay, I got it. Okay, so this approach yields three core advancements that distinguished Dream Zero from prior work, including other WAMs, World Action Models, Kim et al. 2026, Kling et al. 2025. So these are three different things as well in that, like other World Action Models as well.
Mm-hmm.
First, Dream Zero unlocks new generalization capabilities beyond traditional VLAs and previous WAMs across environments, across tasks, across embodiments. Figure 2 and 3. Compared to the state of the art pre trained VLAs, we observe more than twice improvement in average task progress on an environment and task generalization benchmarks. Second, Dream Zero demonstrates that generalist policies can be learned effectively from diverse heterogeneous data, breaking away from conventional wisdom that generalist robots require multiple repeated. Okay. Demonstration per task. Real world execution. Hit the symbol. Generated. What does this fucking mean? Although other world action models show that priors learned from video prediction improve sample efficiency for action learning compared to VLAs. Most work still focus on repeated demonstration. Moreover, environment generalization of Dream Zero is retrained even after specific post training, outperforming state-of-the-art VLAs by 10%. Focus on repeated demonstration. Still focus on repeated demonstration. Even after task specific. What? Moreover, the environment generalization of Dream Zero. is retrained. Moreover, the environment generalization of Dream Zero is retrained even after task-specific post-training, outperforming state-of-the-art VLAs by 10% on an average task progress. Lastly, we demonstrate two forms of cross-embodiment transfer. First, only video-only demonstration from another robot or human yields a relative improvement of over 42% on unseen task performance for the target robot AGI bot G1 with just 10 to 20 minutes of data. Second, and more surprisingly, we show that Dream Zero enables few short embodiment adaptations. A model pre-trained on AGI bot G1 adapts to an entirely new robot with only 30 minutes of play data. Yes, we understand that.
Mhm.
Retraining zero-shot generalization to best of our knowledge, this sets new benchmark for data-efficient embodiment adaptation. Dream Zero is 14 billion autoregressive diffusion transformer trained with teacher forcing chunk-wise video denoising objective. Our architectural analysis reveals that larger pre-trained video diffusion models produce higher quality video predictions, which directly translates to superior downstream action execution, indicating that policy performance is fundamentally tied to video generation quality. Bro, this is what I was telling you. You remember when I was asking you that, like, if the quality of the video would improve the, what do you say, the training of the policy model?
Mhm.
And they have said that over here. Reveals that larger pre-trained video diffusion models produce higher quality video. Oh, larger pre-trained video diffusion models.
Larger
Ooh,
pre it produces higher quality video prediction. That's what it's saying. It's not saying that.
reveals.
Reveals. So our architecture analysis reveals, but
Hmm.
it's for larger pre-trained video diffusion models.
Hmm.
Now we don't know what those models were trained on. That's what they are not talking about over here.
I see, I see. Which directly translates to superior downstream actions execution, indicating that policy performance is fundamentally tied. Yeah, see, performance is fundamentally tied to video generation quality. So the
Mm-hmm.
higher quality of the video generation, the better the policy. We further find that diverse distribution of training data is essential for generalization or performing multitask with the same amount of hours. We observe that autoregressive architecture We observe that autoregressive architectures lead to smoother robot motions and higher modality alignment between predicted videos and executed actions. Autoregressive. Okay. Higher modality alignment. What does this mean?
What? With higher modality alignment between predicted videos. I don't know. Google.
In context of Dream Zero, people are reading this highlights why researchers shows auto-regressive design over bi-directional one. Oh, this is the. I think this is auto-regressive bidirectional, the transformer, I think.
Hmm. I don't know what is bidirectional. It says auto-regressive design over a bidirectional one.
Yeah, bidirectional is the usual one that they.
To understand, image the difference between a model that tries to create a whole 5 7 clips at once versus one that generates the video actually frame by frame, a chunk by chunk, auto-regressive.
Mm. Bidirectional model. AI often struggles with the jitter because it's trying to predict the whole sequence of movement simultaneously without a strong sense of what happened exactly a millisecond ago. Auto-regressive models work like a conversation. Each new action is based on the history of previous action. Because the model remembers where the robot's arm was in the last frame, the transition to the next position is mathematically consistent. This prevents the robot from taking jerky movements. I see. But what does model alignment, higher model alignment? Okay. Modality
So,
alignment is fancy AI speak for making sure the video the AI imagines and the actions the robot takes actually match up. Oh, it's just saying that it's gonna, you know, if
like it's saying,
AI imagine video
is it
helping.
imagining some, if it's imagining something, and is it doing the same thing or not? That is basically what modality alignment means over here, I
Yeah,
think.
yeah, 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 yeah.
So,
It's
for
fancy
example,
speak.
we are imagining that hey, I want to pick up a dumbbell and I'm picking up something like a bottle of water. So that would be like modality misalignment at this point.
Okay, done.
Mm-hmm.
To address the computational overhead inherent to video diffusion models, we introduce a suite of optimizations spanning three categories: algorithmic improvements, including decoupled video and action denoising schedules, Dream Zero Flash, the system level parallelism and caching strategies, and low level optimizations such as quantization and CUDA kernel tuning. Collectively, these techniques achieve 38 times inference speedup without degrading performance, enabling Dream Zero to generate action chunks approximately 7 Hz for smooth real-time robotic control.
100 is 143 milliseconds
Yeah.
downtime.
We introduced Dream Zero. Okay. Non-repetitive robot data. 2x improvement in zero-shot generalization to one scene verbs and motion compared to state-of-the-art VLAs. by retraining generalization across objects and environments. We present model and system optimizations, achieving 38 times inference speed up, enabling real-time closed loop control at 7 Hz. We demonstrate cross-embodiment transfer, video-only data from humans 12 minutes or robots 20 minutes yields relative improvement of 42% on unseen tasks, and it reduced few-shot embodiment adaptation. Dream Zero pre-trained on AGI bot G1 adapts to an entirely new robot. Only 30 minutes of play data. We open source our model-based inference code publicly available Roborina. Bro, what is Robo Arena?
It's I think an NVIDIA Omniverse gym where robots can train and test out a lot of things.
Ah, okay. So we've completed that section as well.
Yes.
We can stop here today.
Yep. Yep.
Good progress. We have done
Yes.
4 pages of this research paper completely. Oh. Mhm. Okay, I'm gonna end the stream. Not a lot of views today for some reason.
And dude, we were streaming a bit earlier. People are waiting for us to stream around 12, right?
Sure. Cool. 1, 2, 3, end stream. Bye, guys. Okay.